This is TechSNAP, Jupiter Broadcasting Systems, Network, and Administration podcast. My name is Wes, and I'm glad to be joined once again by Jim. Welcome to the show, Jim.
Hi, everybody.
Now, since the last episode, you and I have actually had a chance to meet. We both went to LinuxFest Northwest. It was a ton of fun, and while, honestly, I didn't get quite as much time to hang out with you as I would have liked, in that time that we did have, a number of interesting topics came up. So I thought today's episode could be us expanding on that.
Sweet. We can talk about WireGuard.
Exactly. So one of the highlights of LinuxFest Northwest was the Jupiter Broadcasting track. We had our own track, our own room, tons of Jupiter Broadcasting people there, packed rooms, as I'm sure you experienced. I know because, well, all right, let's be honest here, audience. I wanted to go to Jim's talks because, one, Jim's great. Two, I want to show support. And three, your talks were on WireGuard and ZFS, which are obviously two things I'm very interested in. Unfortunately, by the time I got there, the rooms were already packed. So I think it was a huge success. I didn't get to go, and I'm sure many audience members didn't. So maybe we can dive a little bit more into WireGuard. Now, we have talked about it before on this show, in fact, with you, but that was over 6 months ago, and it was before you were a proper host on this show. You were good enough to come on as a guest host, give us some of your insights, but honestly, that was early in the WireGuard story, and a lot has changed.
Yeah, it was pretty early, and a lot has changed. When we started talking about it, I was enthusiastic about WireGuard, but it was still a little early in my own adoption process. At this point, I have completely gotten rid of OpenVPN from my own infrastructure and replaced it with nothing but WireGuard. And I've written a little bit of tooling to, automate onboarding new systems and new clients onto my WireGuard mesh infrastructure. And, I had some time to see how that all plays out.
When we first talked about this in episode 390, well, that was November 22nd, 2018. And people were just getting started adopting it. And one of the nice properties about WireGuard, it's super simple, right? Like you're basically defining some connections between various hosts. What that left to the user, though, was all of the complicated management of a complex multiple machine environment. So I think that's one of the main stories we should talk about that's developed in the past 6 months.
So basically, one of the more complex things setting up WireGuard, or at least different from what we're used to, is if you've got a lot of machines you want to connect together, it can get a little bit more challenging because establishing a WireGuard VPN tunnel is a lot like establishing an SSH connection. If you've ever done that and set up passwordless authentication with keys, WireGuard is extremely similar to that. You've got a relatively short key pair, and you push the public side of that on either side with a little bit of configs, and then you get going. But also, like the SSH sessions, it's a single tunnel. There's not. By default, you're not going to have like an entire subnet available. And if you want to figure out how to connect a bunch of machines and have them addressable between one another, then that's the thing that you need to work out on your own.
Right. Just like SSH, when you have 1, 5, 10 machines, it's not a big deal. But when you're managing whole clusters or several data centers, suddenly just the organizational overhead on there, you're going to need some tools and support. Maybe a personal project I've been working on illustrates some of this difficulty. So Jim, are you familiar with the Tink VPN?
To the extent that I know what it is, that's that is one of a fairly long list of VPN-ish type projects that I was like, oh, that looks cool. I should play with that someday, and never really did.
It's basically a neat, but honestly a bit slow, fully meshed VPN system. So you can set it up on nodes, and it establishes an overlay network that you can then, subnet and address however you like. And then you've got a mesh VPN setup where you can talk to any other node on the network. The nice thing about it is that it will intelligently route if there's, failures within that network. And you may not get that with WireGuard, but it's a separate user space thing I have to install. It doesn't get anywhere close to line rate. So I've been working on replacing that setup with WireGuard. The nice part about Tink is once you got all the keys exchanged, it did the rest. With WireGuard, there's a lot more left to the user.
I'm kind of interested to hear you say that, Wes. So what are some of the challenges that you've seen trying to figure out with WireGuard specifically?
I had to establish a mental graph of what my network looked like. And with Tink, as long as they could all communicate together, there's obviously the usual NAT, ICE sort of busting that you need to do. But once you got through that, Tink would establish mutual connections to each other. Now, each server needed to have, the keys for the other servers it was going to communicate with, of course. But beyond that, the network topology would be automatically configured. And with WireGuard, it felt a lot more like an IPsec star sort of configuration, where I really had to think about each of the links in the chain. And I don't think that was a bad thing, but it was definitely a little bit more involved.
Yeah, your topology is generally going to be pretty simple with WireGuard. Although again, technically everything is peer-to-peer and there is no such thing as a server. In practice, if you want to connect 10 or 20 machines together, you're usually going to have a simple hub topology. You'll have one peer that all of the individual, I hate this. Technically, you say peer-to-peer, but I'm just going to go ahead and make the call. If you have one machine that's a hub for 20 other machines to talk to one another, and you need that, one in the middle, I'm just going to go ahead and say that's a server. So, it's going to be a simple star or hub-based topology where all of your clients, out in the periphery, talk to this one central client, and when one of your peers out on the edge wants to talk to another one out on the edge, it all has to go through that hub in the center. So, I think one of the things that throws a lot of people about WireGuard when they're, coming into it from IPsec VPNs or OpenVPN or what have you, is that since everything is a tunnel, you can set things up in terms of a subnet, sort of, kind of, but you have to realize that it's actually not really. You have a tunnel to your one server machine that is capable of reaching all the other machines, even if they're on the same subnet. There's no network address, there's no broadcast address. And when you don't have a network and a broadcast address, that means you can't do DHCP. So everything is going to need to be statically configured in terms of the IP address configuration, and you need to work that part out for yourself.
Right. Unlike things like OpenVPN, this is a layer 3 connection only. So just suddenly you've got this new layer 3 extension on your network. You've got to think about how does routing and NAT work on that?
Yeah, that's a good point, Wes. It is layer 3 only. There is no layer 2, and you can confirm that for yourself on any machine that you've got a WireGuard interface up and running. If you do an IF config or an IP show on that interface, you'll see the MAC address is listed as all zeros all the way across, and that tells you for sure we are not looking at a layer 2 network here. The flags for IF config actually show WG0 up point to point running and no ARP.
Yeah, we don't need any ARP here. It's 2019, and we've got ourselves a very nice layer 3 VPN. Now, one of the things that struck me in the past 6 months, obviously WireGuard was kind of first targeted at Linux. Now, we haven't seen it make it upstream yet, but that has not stopped a proliferation of official and unofficial client implementation. So, while 6 months or 10 months ago, you could compile a WireGuard module yourself and run it on your Linux box. Now you can install an iPad app.
Yep, you can install an app on your iOS device or your Mac or a FreeBSD machine or even a Windows machine now. Although that last one is still, Jason describes it as pre-alpha, and it works pretty well in my limited testing. But I will say that it is definitely still alpha quality.
I imagine some of that is because, the WireGuard project took off a lot in that implementation, because if anyone who's used a lot of, OpenVPN on Windows can tell you, the existing sort of what one would call a ton driver on Linux infrastructure on the Windows side, at least for open source projects, wasn't exactly great. And the WireGuard project didn't want to rely on that sort of shaky infrastructure. So they've been working on implementing a new architecture on Windows, right?
Yeah, exactly. What you're referring to with OpenVPN was the OpenTap interface, and it is a terrible, buggy mess. I can't tell you how much time I've spent, disabling those interfaces, re-enabling those interfaces, deleting them, installing new ones. And, hilariously, one of the things that they screw up on the absolute most is, for whatever reason, they'll just lock up and not actually get, an address over DHCP. So the very thing that some people are complaining about not having in WireGuard, the DHCP client, it's kind of like, well, it didn't work right in our other VPN options anyway, so I can't really say I miss it.
Very well put. Actually behind the scenes, we have a few WireGuard connections set up in the studio, and the mixer, the Linux-powered mixer we have, has an app you can use to connect to it. So when we're remote and broadcasting live, we just fire up our WireGuard VPN, and then we've got an interface that can control all the live production of the show. And it's just been rock solid, whether that's on a tablet or a desktop Linux machine.
Yeah, it really has been nice. I've been using WireGuard, quite a lot since I first started playing with it. I got it running on my tablet pretty quickly, and I replaced OpenVPN with it, and it's just been a joy. I used to really think about when I wanted to start the OpenVPN client on my phone or my tablet because it was a significant power drain. The speed part wasn't usually a problem, over Wi-Fi anyway, whatever, it was fine. But man, the power drain was significant. I would go from having, about a day and a half of battery with the usual mixture of, apps and browser and games and just whatever that you do on a phone or a tablet, down to, I'd be scraping by for battery by 1 or 2 p.m. And with the WireGuard client up and running, I just don't ever deactivate anymore. WireGuard is just always on my tablet. I don't notice any speed slowdowns, and I don't have any battery complaints at all. I can't really say I notice a difference from running naked.
That's amazing. I feel at this point we've been talking some high praise for WireGuard so far. There is one thing that I still find disappointing, and we touched on it a bit already. WireGuard is not yet in the Linux kernel. What's going on, Jim? We've seen Linus Torvalds express his own compliments towards WireGuard. Many different people have adopted it because it is simple and state of the art. Why don't we have it in a modern Linux kernel yet?
Oh, we don't have it. We don't have it in mainline in the Linux kernel yet because it's a long process getting a new project adopted into the kernel. Unless you remember the Butter project, it turns out the Linux kernel developers are extremely picky about how your code is written and exactly how well it integrates and how reliable it's going to be.
They are acutely aware that once it's merged, it's basically going to be supported forever. Now, of course, legacy subsystems do get dropped from time to time, but most of them hang around. It pays to get it right. Now, correct me if I'm wrong, Jim, but I believe some of the hang-up is because while WireGuard appears as a very simple, it just reuses a lot of the existing sort of network interface structure in the kernel, it did also come with its own rather controversial crypto subsystem.
Yeah, it uses something called Zinc that wraps up a lot of its crypto functions. It was the right way to go. Jason didn't succumb to not invented here syndrome and decide to, write his own right from the bare metal applicable to nothing but his own project crypto routines. He incorporated a more basic library called Zinc, and a lot of the work that's been going on to get WireGuard ready for inclusion in the kernel is figuring out exactly where the code boundaries are between WireGuard and Zinc, and making sure that Zinc itself is both ready to go in the kernel and will be available in all the ways that it needs to be, in order to be the much more available general purpose library that it really is, and not just a crutch for WireGuard.
What that says to me is if this is done right and it's all successful, not only will we get WireGuard in a future upstream kernel, but there will be a nice new layer of crypto APIs that other future kernel facilities can take advantage of. And really, it's the same sort of simple interface, right? Where you don't have excess choice. You just make the right decisions by default.
I don't know that I'm really qualified to tell you about, what you can and can't do with Zinc and whether it's possible to use it wrongly. I don't know enough about that library to speak authoritatively on that, but I can say that, getting the modular design right on something like that so that you maintain as broad a degree of functionality as possible on a basic library rather than making it just something that's only applicable to this one project. That's one of the things that's key to get right when you incorporate something in the kernel, and it's not easy. It takes work. So Wes, before we move on from WireGuard, I do want to circle back around to the Windows client real quick, because I know people have really been chomping at the bit for that for a while. There's a third-party Windows client that has been available for a while. I don't recommend that one, in part because it does rely on that OpenTap adapter, which I really just do not like the cut of that thing's jib. We talked a little bit earlier about how Jason was putting a lot of work into getting the modularity of the design right for implementation in the Linux kernel and drawing a clear boundary between Zinc itself, which exports a lot of cool crypto functions that can be used for a lot of basic things, and WireGuard, which is, more of a complete project that is layered on top of Zinc. Well, he's taken that same kind of careful approach to the Windows client, which, again, is still, in active development. It's in a pre-alpha state right now, but it is largely working. But the first thing that Jason needed to get right was a workable network interface driver below that thing. We've already talked about how the OpenTap adapter is basically a flaming pile of poo on Windows. And Jason had originally thought that he would work with Microsoft's existing VPN adapter that they use, for their own IPsec interface. But what he found is that I'm not super clear on the details, but he was really, really unhappy about that as well. So he built a project called WinTun first, and he had to get WinTun right. WinTun is a layer 3 tunnel driver for Windows, and it does nothing but a very incredibly basic layer 3 tunnel interface driver. It doesn't have all of the configuration stuff or all of the crypto stuff or, all the things that make WireGuard. It's just basically the world's simplest possible, super dumb, but because of that, rock solid and easy to maintain layer 3 tunnel driver. So that's good to know that, we've got the same kind of careful design, and that's part of why it's taken so long, to get to where we are now with the WireGuard Windows project. And I can say that where we are now is pretty exciting. He finally publicly announced the client, and you can download the alpha and install it directly. It's got signed drivers for WinTun so that you get, no scare messages when you install that on Windows 8, Windows 10, Server 2012, Server 2016, even Server 2019. It just installs and goes and doesn't complain about driver signing or anything. For the most part, getting it running was pretty easy. I did discover a bug that the Windows client shares with the Android client, actually, which most people probably won't experience. But if you're like me and you set save config equals false on in your configs because you didn't want something overwriting your nice careful commenting in your config file, neither the Android client nor the Windows client understand that yet, and they will fail, so you'll have to go in and edit that out. Beyond that, I just imported my tunnel just like I would with any Linux machine, and it just worked. You get a pretty clean interface that just pops up right after you install the WireGuard package itself, and you import your tunnel into that, and it automatically activates, and you go. The other bug that I did discover relatively quickly, I thought, well, let's see what happens when I restart my Windows VM. And I think what happened is that on restart, WireGuard does try to automatically activate any of the tunnels that you've got. And it looked like it tried to activate the tunnels before the network stack was completely up. So it just froze on activating forever. So I had to open up services, go through and find the individual WG0 tunnel service and, just stop that. And then I could go back to the interface and it showed that it was deactivated and I could activate it again. And like always with WireGuard, then it just connects in about 1/10 of a second, and you're good to go. So it's pretty exciting stuff. I'm really looking forward to the project actually getting out of alpha. I feel like it's so close now I can taste it. I will say that I don't think anybody should be relying on the Windows client in production right now because, it did not take long to find a couple of bugs, minor than they might have been. And Jason has specifically warned that the internals of the Windows client aren't locked down and secure to his taste yet. So it's entirely possible, if you've got an attacker on the same machine with you, they might be able to sniff pieces of the key, out of memory in the system from another process. All that nasty stuff that's really hard to nail down and get exactly right. That stuff's not ready yet.
It really is an exciting time to be a WireGuard user. We'll have links to all the stuff Jim just talked about, including WinTun, in the show notes, techsnap.systems/403. We'll also have a few other things that I've seen pop up, including a couple different options, one of them actually by you, Jim, but we're seeing a whole field of WireGuard configuration tooling available. So you've got some scripts set up. I've also seen a online web-based GUI that you can use to sort of manage all your different WireGuard hosts. And there's even a WireGuard mesh network operator for Kubernetes. So There's a lot to look at. Head on over to TechSNAP.systems. You'll find links to everything. All right, well, that's enough on layer 3. Let's jump down a bit and talk about layer 2. Well, I didn't make it to your WireGuard talk, Jim. I did stop by afterwards, and I stumbled into a little bit of what I think is maybe a Jim Salter hot take, and that's about VLANs. When you start getting a little more advanced in network configurations, you think to yourself, oh, VLANs, this is neat. I can have these separate, secure layer 2 networks. Really, it's not quite that simple, is it?
No, it's really not. This is actually one of my pet peeves, and it's definitely a Jim Salter hot take. It's frequently a very unpopular one because I crap on a lot of the way that a lot of admins set up their networks. I see a lot of these small business and, even mid-market networks set up that are just, they're riddled with VLANs for no apparent reason. You've got your servers on one VLAN over here, and you've got Windows machines on another VLAN there, and your Wi-Fi is maybe on another one. I've seen networks with up to 10 VLANs on them for no real apparent reason. And when you talk to the admin who set them up, the answer you get is always the same. Well, I do this so that I have, my separate networks of machines segregated from one another. And, I have to worry less about, what one machine is doing talking to another machine because they're separated. They're on different VLANs. But every single time, what I see is that, when you actually get down to the individual machines, what controls which machine is on which VLAN is not what port of the switch that they're plugged into. It's literally just the configs on the machine itself. Now, it's one thing to say, okay, so I've got VLAN 2 and I've got VLAN 99, and I have half the ports on my switch locked down to VLAN 2 and the other half are locked down to VLAN 99. So at that point, if you just plug into a machine into the switch and what port you've physically plugged it into determines what VLAN you're on, yes, that is a security feature and you've got segregation.
Right. Basically, you're just relying on physical security then, right? You're assuming that people can't just be plugging in random machines to random ports because maybe it's at a controlled access facility.
Well, absolutely. But, any good sysadmin knows once you've got physical access, game over, right?
Exactly.
But that's not what I see. I can't say that I've ever actually seen a port-locked VLAN config on a switch unless I personally configured it. It's always just tons and tons of VLANs. The machines get to tag their own packets. And if that's what you've set up, you don't have any segregation. There is absolutely nothing stopping anybody from just saying, I'm going to reconfigure my system to be on VLAN whatever I want to and touch whatever I want to directly. And if that's the case, well, at that point, you might as well have just had a bunch of different subnets all on the same VLAN because you don't really have any more effective segregation.
Right. Without security, you've just got not really segregated layer 2 networks. And maybe it would help to talk a little bit about some of the basics of VLANs or the intentions behind this. I liked what one of the audience members said. I think many times VLANs get set up because you just don't want to spend the money on a second switch.
So the thing about that is that can be a valid reason to use a VLAN. You say, well, I need to have 2 or 3 separate networks, and they need to be isolated. But I've got 48 devices, and I want to just have one big 48 port switch, and not have a 24 port switch and a 16 and a couple of 8s. That makes sense. But again, unless you're actually locking these things down where the tags are, mandated at the switch level and not just something you arbitrarily get to do on every machine by itself, there's no point.
Do you have any advice for someone identifying a sane VLAN configuration? Do you have like a heuristic to identify, do VLANs make sense in this environment? And am I really gaining anything?
In terms of security, you're almost never gaining anything. Unless the VLAN is actually enforced at the switch level, you haven't actually gained any segregation or isolation that means anything. Anybody can still set their machine to be on any VLAN they want to, and the only person whose life you've made more difficult isn't an attacker, it's your own.
That's a great point, because if you can tag your own packets, any machine that gets compromised on the network can choose its VLAN at will.
Absolutely. And, you've bypassed any kind of concept of real security or isolation that you had because, of course, you don't have any firewall keeping these arbitrary machines from talking to your super secure VLAN that your servers are on. They're secure just because they're on a separate VLAN, right? Only, now they're not. Anybody with their laptop can just be on the same server as your VLAN and hit them directly.
Okay, Jim. If I'm not using VLANs, how do I isolate different networks, right? Maybe I have a staging environment and production, and I really don't want the two to mix.
Well, so basically the way that you isolate them is the same whether you've got VLANs or not. Ultimately, what you have to do is you have to make sure that you've got a firewall in between separate subnets, one for your servers and, one for your less trusted workstation type machines or whatever your boundary is and the reason that it's there. It boils down to you need to have these machines on separate subnets. And you need the only way for one group to be able to touch the other group is to go in between a router with firewall rules on it. Now, this is actually what you do whether you've got VLANs or not. Without VLANs, you need separate physical devices for this. You would have one small switch for your servers, one larger switch for your clients, and a router that sits in between the two and passes packets according to whatever firewall rules you've got set up. You do the same thing with VLANs, only there's only one switch, and it's possible to do it properly. To do it properly, you would have, say you've got 8 servers and you've got 40 workstations, and they're on a 48-port switch. You have, ports 0 through 7 locked down to VLAN 100 or whatever arbitrary, number you want to use for your servers, and then the default VLAN is on, ports 8 through 47 for your workstations. But in both cases, the VLAN that you're on is mandated by the switch at the hardware level, so you can't escape it. Now, underneath that, you're still doing the same thing. You still have a router in between the two subnets. You've got a firewall that does or does not allow packets from the individual subnets according to whatever security rules you have. The only difference is the VLAN didn't give you extra security. It just allowed you to do this all on one switch rather than having to have separate physical pieces of equipment. Now you can have one DHCP server that's running on your server subnet. Maybe that's running on a Windows Server machine, or maybe you've got ISC DHCP server, or maybe it's running from the switch itself. But you have a separate DHCP server, you've got separate subnets, you've got separate network and broadcast, the whole nine on ports 0 through 7 and on ports 8 through 47. And they're effectively, at this point, completely separated. But again, the key there is you have to be enforcing that separation on the hardware level at the switch. If you just allow any machine to tag its packets with any VLAN it wants to, you might as well just left them all on the same subnet to begin with.
All right, well, that makes some good sense. If we exclude isolation, are there any other good reasons to use a VLAN?
Yes. Basically, because the QoS functionality on your router sucks. There are a lot of routing devices out there, and pfSense is very much one of them, and you find pfSense everywhere in the real world. In theory, you can do QoS and traffic shaping just fine, based on layer 3 and IP addresses. You don't really need to do it at the layer 2 level. But a lot of the actual routing devices out there that people are really using, again, including pfSense, they have really good facilities for doing QoS on everything that has a particular VLAN tag on it, but they're not so good at doing it on a layer 3 basis. So in the real world, you'll see a lot of perfectly sensible setups where you have, VoIP phones and computers that they're all on the same actual physical network. They're sharing wires, but they're on separate VLANs. A lot of admins will get confused and they'll say that's to isolate them, but it's really not. The good thing that you're getting out of that is the ability to now quickly and easily say, okay, everything on VLAN 100, those are my VoIP phones. They should have the absolute highest priority, low latency going out to the internet, and you slap that onto that VLAN tag and you're done. That
is a great example. And it does show, it's a useful tool. There are things it can simplify or make cleaner in your network architecture. But it's not a one-stop solution for all of your networking problems. And like anything else you're setting up, you really need to think it through.
Yeah, you have to understand it. So as a sysadmin myself that inherits a lot of clients, I see a lot of what other people have done. And, when it comes to virtualization, I see something very similar where it is really not uncommon at all for me to walk into a shop, a small business, and see one Windows server sitting in the corner running Hyper-V with one Windows Server VM on it. And there's no snapshots, there's no replication. The virtualization doesn't help anything, but by God, they ticked that virtualization box. Nobody's going to accuse them of not being with it.
Well, we've got one more hot take for this episode. And honestly, it's something near and dear to my heart. I think there's a bit of a cultural misunderstanding here, and sometimes a bit of misplaced shame. What I'm talking about, in plain terms, is high availability. And if you've been in the admin game, it's held up to this standard, right? We all want our services to be highly available, with no downtime. But really, that's not possible. Or if it is, it requires serious trade-offs and consideration. And this is just one more area where you really need to understand what you're talking about and think through the rationale. And Jim, I loved your approach on this because at the end of the day, it all comes down to how available do you need your service to be and how much downtime can you tolerate?
And, how much can you actually spend and how much complexity can you actually properly maintain, trying to chase this mythical 5 nines or, a 1, just nothing but a 1. There's no 9s. It's just a 1. That's what everybody wants. So if you're not familiar with this game, the idea of 5 nines is, 0.99999, meaning that your service is up 99.999% of the time. That means that you can only have downtime for a little under 5 minutes per year. And the big thing that you have to chase in order to achieve this kind of uptime to get high availability is you can't have any single point of failure. And the way that you typically approach that is you say, okay, so I need super high availability. That means that I need to be able to bring things down for maintenance without bringing my service down, so I can't have any single point of failure. So what I do is I set up these 2 machines, either of which can do the job that I need them to do, and then I introduce a load balancer in between the 2 that will automatically pick the one that's still up. And so at the end of the day, what you've done is you've taken 2 machines that might go down, thereby, being a single point of failure, and you've introduced a single point of failure in front of them.
That's a great point. Now, there are configurations, right? You can have 2 load balancers that pass off and communicate with each other. But we should underscore that not only does that usually cost hundreds of thousands of dollars, but it is a complicated stateful mechanism being passed between those 2, and it is not foolproof.
No, it's not. And, okay, great. So now you have 2 load balancers, either of which hopefully will work to connect to your service, but how do you choose which one of those you're going to connect through? Because at the end of the day, you're connecting from one computer that needs to just connect to one thing that needs to be up. So what bridges those 2 load balancers together to the single IP address that you're going to expect? Because if your device is going to connect to any of a number of IP addresses because you're using round-robin DNS, well, now all of those have to work all the time, or you have downtime.
No, to be clear, it's not that having a highly available service is bad. We all use and trust services that operate with considerable uptime. A great example is the traditional phone system, right? It's just not okay if you can't place a phone call, or at least it's a very irritating incident. But not all of us operate nationwide phone systems, and not all of us are Google. What process do you go through, Jim, as you're deciding what's the right level of availability? Obviously you need backups, you need disaster recovery, maybe you need a active-passive setup or a truly highly available active-active system. Do you have any helpful tips to sort of decide what's right for you?
Well, the biggest helpful tip is, you have to look at your entire application stack. And if the entire application stack wasn't designed for high availability, then the answer is no, you can't have it. You don't want it. And it's not going to work the way that you expect it to. The example that you came up with the phone system, It's a great example of something that people expect to be up all the time. It's not a great example of a high availability system because it's not a traditional HA system. There's all kinds of single points of failure in the phone system. You've got the last mile of wire that's going out to your house. You've got the device that it's plugged into. There's very little in terms of what HA really means going on in the phone system. What the phone system really is more than anything else is it's relatively simple and it's extremely reliable and well understood, and it's managed by engineers who understand it very well and can plan for downtime and have downtime in ways that don't bring the entire system down for everyone.
There's two key takeaways from what you just said there, Jim, at least for me. One is you have to plan for downtime because no matter how good you are, it's just going to happen and it's going to be a complicated mess you have to recover from. So the simpler your systems are, the better. The other one is reliability versus availability, and maybe you can expand there.
So I think, maybe to talk about the difference between reliability and availability, we have to kind of pivot a little bit and go into, one of the really important terms to understand when you're planning for a system that you can trust to be there when you need it. And the key term here is mean time between failures. And this is a term that I really like because you don't really need like a special IT dictionary to figure out what it means. It means exactly what it says on the label. It's the most common amount of time that goes in between the system working and it breaking. And the thing that most people don't realize about high availability is that in the vast majority of implementations out there, your mean time between failures doesn't go down when you implement HA. It frequently goes up because you've introduced a lot more complexity than you had to begin with. Now, instead of a server designed to do a task, you've got multiple servers designed to do the same task, and you've got a complicated fencing algorithm that's supposed to figure out which one of them is up, which one of them is down, which one should be the master, which one should be the passive. You've also increased the severity of the possible failures you can have and how long it takes to recover from them. A term that you might have to look up to understand some of these things is a split brain scenario, but it's the first term I think you should understand if you're seriously thinking about HA. It's fairly easy to explain. Basically, you say you've got two servers that are both capable of servicing the same requests. And the idea of your fencing and your load balancing is it decides which of these servers is up and which of them should I be sending these requests to. If one of them goes down, then your fencing algorithm is supposed to understand that and start routing everybody over to the server that's still up, which has now become the master. Now, the problem with this setup is it is incredibly likely that you'll have a failure where the fencing doesn't work right and you end up with half of your users actively using and writing new data to and deriving functionality out of one server that thinks it's the master, and the other half of your users are now doing the exact same thing with the second one. But both of those servers think that the other one is down and, they're the only real kid in the room. This can take a while for users to figure out what's going on because everything appears to work fine, but eventually they notice, hey, I'm not seeing this data that I did yesterday, or, Bob on this side of the room isn't seeing the data that Alice put into the system on the other side of the room. And that's when they call IT in and you figure out, oh no, we've been operating for a day and a half with half of the office working on one system, half of the office on the other, and there's no good way forward now. I have to manually reconcile all of this data and all of these conflicts in order to go forward, or I have to tell my users, sorry, but the last day and a half of productivity effectively didn't happen. You're gonna have to do it all over again because that's the easiest way to actually get all this stuff together in one place.
The downside of if HA works, if the system, if everything goes according to plan, well, that's great. The downside is you get way more complicated failure scenarios.
And all too frequently, those failures actually do happen more often just because the system is that much more complicated and it has that many more moving parts in it. It's pretty similar to RAID. A lot of people think that, well, I have RAID for my storage, a redundant array of inexpensive disks, so I won't experience failures so frequently. That's actually not the way it works at all. You have failures considerably more frequently with RAID. The idea is that hopefully the failures won't hurt you when they happen. But if you've got an 8-bay server with 8 disks in it, and you've got a striped RAID array running across all those 8 disks, you now have 8 times the number of possible failures that you can have. You're hoping that none of those failures will bring the rest of the system down with it, but in actual practice, it's entirely possible for a disk in a real-world storage array to fail in a way that brings the whole thing down until you can pull the offending disk that's locking up the entire SATA or SAS bus. You've also, again, you've introduced a new single point of failure. Now you have a RAID controller of some kind in front of all these things, and if that fails, it's a single point of failure and everything goes down with it. At the end of the day, you really can't get away from single points of failure. You can try to put a single point of failure that has a higher mean time between failures in front of more complex components in your system that are more likely to fail and implement some kind of redundancy between them. But you really, really have to know what you're doing. You can't just slap it all together and expect a good result.
Maybe we should take a step back for a second and just define some terms, because there's a lot of them being thrown around. High availability, fault tolerance, and disaster recovery. Now, those all have sort of common sense definitions, but maybe you can expand a bit, Jim, and give us a clue as what those really mean in practice.
Actually, Wes, instead of talking about high availability versus fault tolerance and disaster recovery, I want to take a step even further back. Let's stop with the IT mumbo jumbo for a second and use business mumbo jumbo instead. There are these terms that I find nowhere near enough sysadmins are familiar with, and they really should be, because they really dive down to the heart of the matter. The two terms you should absolutely understand as a sysadmin so that you can talk to those pesky business types. To be fair, you may need to explain them to them as well, but it will strike to the heart of what they care about and what you should care about. Those terms are RPO and RTO. RPO is a recovery point objective, and RTO is recovery time objective. And what that boils down to is, if you have a failure, your recovery point objective states how much data is it tolerable for me to lose if I have a system failure of some kind. Now, let's say that you've got a very old school, very traditional system where you have a tape backup that runs automatically every night, and you've got a rotation of tapes that you ship in and out. Well, your recovery point objective for this system is going to be within 24 hours, because you run that backup once every night, probably at midnight. So the most amount of data you can lose, assuming everything's working fine in your backup system itself, is 23 hours, 59 minutes, and 59 seconds. So now that we understand the recovery point objective, let's talk about recovery time objective. We're going to pick on our same old school, small business with a tape backup that runs automatically every night. We're still going to assume that everything is running correctly on this. Your recovery time objective is going to be how long it takes you to actually get the data back onto your system, get everything configured and running again, and be able to get back to business as usual. And your recovery time objective frequently is even more sensitive than your recovery point objective. I can tell you, I've encountered a lot of businesses that could tolerate losing a day worth of data, or even a week worth of data if they had to, and it wouldn't be the end of the world. But when you ask them to be down and not running at all for the same 24 hours as you had in your recovery point objective, now you've got a problem. They need to be able to get back to work. They need to be able to get back to work right now. So that's why your recovery time objective is important. Now, for my own systems, I target a really low time and point objective. I want to have less than an hour on both sides. And my recovery point objective in particular, I want to be able to be back up within 5 or 10 minutes. That's why I do everything on VMs. That's why all my VMs are on ZFS. That's why I take snapshots. That's why I replicate them between machines. I want to know that no matter what happens, I can bring everything up from not too far back, and I can do it immediately. Once you understand your actual RTO and RPO objectives, what you find is that in almost every circumstance, you can satisfy that, and without injecting the kind of danger that comes along with high availability, where now you've injected this complexity into your process that can mangle your data even worse than if it had never been there at all.
I like how you've drawn the distinction between business terminology and IT terminology, because really, one is here to serve the other, right?
That's one thing that I think very few sysadmins get right. They don't understand that they're not there for the equipment. They're there for the business. They're there for the mission. And, the whole IT world has been going super blazing hot for DevOps for years now. And it makes a lot of sense. Devs need to be able to talk to the operations side and vice versa. But the thing that nobody really talks about, and they ought to be, is BizOps. All these folks on the system administration side, we need to be able to speak the language that the business people know. We need to talk about what it actually takes to keep the business rolling and make sure the business can do what it does, keep the money coming in, and keep our salaries paid.
That's right. At the end of the day, if the business doesn't keep going, well, it doesn't matter how good our systems are.
No, it does not.
Well, that's probably plenty of hot takes for this episode, but if you'd like to catch a little bit more of Jim, we've got some recordings of his talks at LinuxFest Northwest up on the Jupiter Broadcasting GitHub. Just head on over to techsnap.system/403 to find that and all the other links for this show. If you're at all interested in Linux or security or anything in between, you might also like our upcoming security study group, Command Line Threat Hunting with Tony Lambert. This is a great little introduction into understanding the various threat vectors on a common Linux system. So if you've ever wondered to yourself, how do I know if I'm infected and what do I do? This is the study group for you. It's taking place Tuesday, May 14th at 5:30 p.m. PST. If you'd like to register or find out more, just head on over to meetup.com/Jupiter Broadcasting. And finally, if you'd like just a little bit more Jim, you should really check out his recent article over at Ars, which is all about quantum key distribution. If you're not familiar, well, just go check it out anyway, because this is one of the best breakdowns and introductions to quantum computing and quantum cryptography I've seen in years. So great work, Jim, and audience, do check it out.
Wes, all the talks on the Jupiter Broadcast channel were recorded at LinuxFest Northwest, weren't they? Including yours.
Absolutely. I had a talk about lambda calculus and another about Linux audio production. You can find all of that over at our GitHub. If you'd like to send us feedback, head on over to techsnap.system/contact, or you can find us both on Twitter. I'm at Wes Payne, and Jim, you're
at JRSSNet.
Thank you all for joining us.
And we'll see you in a couple weeks.